Good morning. Today we will discuss about the topic tangents and normals. What's a tangent to a curve? We discussed about tangents and normals in IGCSE classes, but we'll discuss once again. Okay, for that let's consider a curve which is a parabola. We can use cubic or any type of curves, but here we are using a parabola for example. Okay, for that let's mark a point on the curve and draw a straight line through that point. Okay, and you can find that straight line touches the curve exactly at one point, isn't it? It touches the curve exactly at one point. If it touches at more than one point, we call it as a secant. What if it touches the curve more than one point? It is a secant, but here the straight line touches the curve exactly at one point, which is named as a tangent. So that graph shows how a secant becomes tangent. Okay, so a tangent touches the curve exactly at one point. That point is known as point of contact between curve and tangent. Okay, now here we need to find the equation of tangent. For that, let's see one example. Question: find the equation of the tangent of the curve y is equal to x square minus 3x plus 2 at the point 3, 2. Okay, so we have to find the equation of tangent, which is a straight line which touches the curve y is equal to x square minus 3x plus 2 at the point 3, 2. So the point of contact is 3, 2. And the curve is already given there, which is y is equal to x square minus 3x plus 2, and we have to find the equation of a tangent, means equation of straight line. Let's see how to find it. Okay, so let's consider the curve y is equal to x square minus 3x plus 2, and the point is mentioned as 3, 2. Through the point, let's consider a tangent, a straight line which touches the curve exactly at the point 3, 2. Now let's see how to find the equation of tangent. And to find the equation of tangent or any straight line, we require a term known as gradient. Because remember the equation of a straight line, which is y minus y1 is equal to m of x minus x1. In IGCSE classes, we learned the equation of straight line as y is equal to mx plus c. But here in AS level, we have to use y minus y1 is equal to m of x minus x1. So here m, what is m? M is the gradient, and y1 and x1, that is x1, y1 is the point of contact, where x1 is 3 and y1 is 2. Okay, so we got x1 and y1. Now our task is to find the gradient, and we learned already how to find the gradient with the help of the equation of curve. And we know that gradient is same as derivative of the curve. That means m is equal to dy by dx at a certain point of x. So here what is the value of x? Which is 3. So at x is equal to 3, what is dy by dx? That is the gradient of the tangent, not gradient of the curve, gradient of the tangent at the point 3, 2. So let's differentiate the equation of the curve. Okay, you know the differentiation. So if you differentiate, we get dy by dx is equal to 2x minus 3 2x minus 3 because the derivative of x square is 2x and the derivative of 3x is 3 into 1 plus derivative of a constant is 0. So we get it as 2x minus 3. That is the derivative dy by dx. Now we have to find out the gradient. For that, what shall we do for finding the gradient? Yes, substitute the x coordinate. So to find the gradient, we have to substitute the x coordinate, isn't it? So when x is equal to 3, what is dy by dx? It is 2 into, that means into x minus 3, replace the x as 3. So we get 2 into 3 minus 3. What is the answer? Which is equal to 6 minus 3, that is 3. So we get the gradient of the tangent is 3. Okay, now we got all the required terms for the equation of tangent, which has gradient 3 and the point of contact, which is x1 y1 is 3 2. It's already mentioned in the question. Hence the equation of tangent is y minus y1 is equal to m of x minus x1. Y minus y1 is equal to m of x minus x1. Remember the formula, that is y minus 2, because y1 is 2, is equal to m. M already we found as 3, that is 3 of x minus 3, because x1 is 3. Now we have to simplify it. We get y minus 2 is equal to, expand the bracket, we get 3x minus 9. That is, now we have to remove that minus 2 from the left hand side. That means transpose it to right side. We get y is equal to 3x minus 9 plus 2. That is, y is equal to 3x minus 7 as the equation of tangent. Okay, now our concept is normal. What is normal? So we discussed about tangent. Now let's consider what is normal. So a normal is nothing but it's a line which is perpendicular to the tangent. A line perpendicular to the tangent at the point of contact. Which point of contact? The point of contact of tangent and the curve. So through the point of contact of the tangent and the curve, draw a perpendicular line perpendicular to the tangent, which is considered as the normal. So here you can find a curve and a tangent. Yes, and you can find a point of contact of tangent and the curve. So now our task is to draw a line through that point which is perpendicular to the tangent. Okay, so now we draw a line which is perpendicular to the tangent. That line is considered as normal. Okay, we learned normal in many other places, many other topics, like when you are finding the reflection, a line between the ray of incidence and ray of reflection, we have to draw a line which is known as a normal. These all things we learned in primary classes. So here normal is a line which is perpendicular to the tangent, is considered as normal. So here the concept is perpendicularity. Two lines are perpendicular. Okay, so which are the two lines perpendicular? Tangent and normal are perpendicular. Okay, so the concept is two lines are perpendicular. Remember what happens if two lines are perpendicular. So recall the concept of parallel lines and perpendicular lines from coordinate geometry. Okay, so let's see what happened here. Let's draw a pair of perpendicular lines and a pair of parallel lines. See, parallel lines are not required here because lines are not parallel, but let's recall the concept. That's it. And if two lines are parallel, what's the concept? Their gradients are same. If two lines are parallel, they have the same gradients or same slopes. Yes. And what is the concept of perpendicular lines? If two lines are perpendicular, product of their gradients is -1. So if two lines are perpendicular, the product of their gradients is -1. That means if the gradient of tangent is m1 and gradient of normal is m2, then we can say m1 into m2, which is the product of the gradient, is equal to -1. From this concept, we can find the gradient of the normal m2. So what is m2? How do we find m2? It's just by transposing m1 to the right side, so that we get m2 is equal to -1 divided by m1. This is not a new concept. We learned this concept in IGCSE classes also. But here the concept is repeating just because of derivative, just because of the gradient. There we found in IGCSE classes, we found the gradient by using the change in y divided by change in x, y2 minus y1 divided by x2 minus x1. But here the gradient is found by using the derivative. Only that's the concept getting changed. Other than that, everything is same. There is no change in any other things. So that equation of the normal can be found by y minus y1 is equal to m of x minus x1. But what is m here? It is -1 by m1. Okay. So -1 by m1 is the gradient of the normal. x1, y1 is the point of contact. Find the equation of the normal to the curve y is equal to x cube minus 6x square plus 5x plus 15 at the point 29. So here we are going to find the equation of the normal. For that, let's consider a part of the concept now very clear what to do, and mark the point of contact. What's the first task for us? 29. Okay. Now through the point of contact, let's draw a tangent. We are not in need of the equation of the tangent, but we require the gradient of the tangent. And now let's draw the normal which is perpendicular to the tangent. And as we know, the tangent and the normal lines are perpendicular to each other. We can get the concept very clear now. It's nothing but product of their gradients is -1. Now to find the gradient of the tangent or normal, we need to find dy by dx of the curve. Then means we need to derive the curve. Gradients. Okay, so let's find dy by dx. What will be the product of their gradients? That will be, which is minus 3x square. That is, the derivative of x cube is 3x square minus 6 into derivative of x square is 2x plus 5 into derivative of x is 1 plus 0. That is dy by dx is equal to 3x square minus 12x plus 5. Okay, now what shall we do? Now at the point x is equal to 2, because point of contact is 2, 9. So at x is equal to 2, dy by dx becomes 3 of 2 square minus 12 into 2 plus 5. When we simplify it, we get dy by dx is equal to 3 of 2 square, that is 3 into 4, 12, minus 12 multiplied by 2, second term 24 plus 5, which is 17 minus 24. 17 minus 24 is minus 7. So gradient of the tangent is minus 7. So our new task is to find the gradient of the normal. So the gradient of normal is, what is the gradient of the normal? Is minus 1 by the gradient of the tangent. That is minus 1 by m1, which is equal to minus 1 divided by minus 7. That is equal to 1 over 7 as the gradient of the normal. Now we got all the required materials for finding the equation of the normal, where gradient of the normal is 1 by 7 and the point of contact is 2, 9. That means ordered pair x1 y1 is equal to 2, 9, where x1 is 2 and y1 is 9. So the equation of normal is equal to y minus y1 is equal to m of x minus x1. That is y minus 9 is equal to y1 is 9 is equal to m. M is 1 by 7 of x minus 2. Okay, now let's simplify it. So we get y minus 9 is equal to 1 by 7 of x minus 2. Let's open the bracket. We get y minus 9 is equal to 1 over 7x minus 1 over 7 times 2 is 2 by 7. Now take minus 9 to the next side. For making y as the subject, we get y is equal to 1 over 7x minus 2 by 7 plus 9. So if you calculate minus 2 over 7 plus 9, 1 by 7x plus 61 by 7 as result. Okay, thank you.